Good morning. Today we're on lesson 117, and it's direct and inverse variation again, but parts of the direct or inverse variation will be squared in this lesson. So remember, if A varies directly as B, you would write it like that. If A varies inversely as B, then you write it as a fraction. So that's inversely or indirectly. Okay, that's just for review of what we did before. So in 117.1, the problem says the distance required for an automobile to stop is directly proportional to the square of its velocity. So we'll let V be velocity, and it means velocity squared, the square of the velocity. Once you have that original equation set up, the problem isn't any different than what we did before. We're going to solve for K first. So it says if a car came to stop in 200 meters, that's the distance, at 20 kilometers per hour. That's a speed, which is also called velocity. So that's 20 squared. So this would be 200 equals 400K. Now remember, when I taught you this lesson, I told you that the constants don't always have to come out to be whole numbers. And this is a case when it's not a whole number. 2 over 4 reduces to 1/2, so K is actually 1/2. So remember, we take that K and we put it back here. So we have D is equal to 1/2 V squared. And we can go back and look at the problem. It says, what will be the required stopping distance? So we're looking for D. What will be the required distance? At 28 kilometers per hour. So 1/2 times 28 squared. All right, so we have to square 28 first. Remember your order of operations. 64, 16 to 6 is 22, 16. So 784. So D is equal to 1/2 of 784. And 2 goes in there, 392. So the distance required would be 392 meters. Okay, so really nothing new except that we did square one of the elements in the equation. Okay, so let's look at the next one. It says the distance a body falls varies directly as the square of the time it falls. So time squared. And then it says if it falls 144 feet, is that distance or time? That's distance. In 3 seconds. So 3 squared because the time had to be squared. So 144 equals 9K. Divide both sides by 9. 16, correct? Okay, so we take that and we put it back in here for K. So we get D equals 16T squared. And it says, how far will it fall? So that's distance in 10 seconds. So don't forget, it's 10 squared. So D is equal to 16 times 100. So D would be 1,600, and that was feet. So 1,600 feet. Okay, this one isn't too bad. One more. You can probably guess, since both of those were direct, this one is probably going to be inverse. So 117.3 says the weight of a body on or above the surface of the earth varies inversely. So I'm going to put K over something. Inversely with the square of the distance from the body to the center of the earth. If a body weighs 10,000 pounds, so put that in for W. Put our K in because we know we have to solve for that first. At a distance of 5,000 miles from the center of the earth. Okay, these are going to be big numbers, guys. So 10,000 equals K over, remember the shortcut to multiply with numbers with zeros at the end? If we're squaring this and it has 3, then the new number is going to have twice that. or 6, and then 5 squared is 25. And now we have to cross multiply to get k. So k will be 25 times 1 is 25, and count all the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 5, 6, 7, 8. I'm running out of room. 9, 10. So that's a really big number. So the constant is, what is that, 250 trillion? Thousands? No, billions, right? Thousands, millions, yeah, 250 billion. All right, now we can put that back in, and it might be easier just to go ahead and write this in scientific notation rather than put all those zeros. So that's 3, 6, 9 times 10 to the 11th is equal to k. So I can take that and put it right here. So W equals 2.5 times 10 to the 11th over d squared. Now we'll see what else they want. How much would it weigh? So we're looking for W. 50,000 miles from the center of the earth. So 2.5 times 10 to the 11th over 50,000 squared. All right, so 50,000 squared. That would be 5 times 5 is 25, and there's 1, 2, 3, 4. So there'd be 1, 2, 3, 4, 5, 6, 7, 8 zeros, right? Okay, so now let's write that in scientific notation as well. It'll make it easier to solve this. So we have 2.5 times 10 to the 11th over 2.5 times 10 to the 369. So what is 2.5 divided by 2.5? It's 1 times 10. Now remember, because we're dividing, we subtract those exponents. So 11 minus 9 would be 2. If you want to leave it that way, that's fine. But what is 1 times 10 to the second? It's 100. All right, so that's that lesson. All we're doing is we're squaring some dimension of the ratio. Okay, nothing else is different. All right, thanks guys. Have a good day.